This YouTube tutorial will explore threading in Rust. Rust, being a safe language and strongly typed, is well suited to parallel programming. However, of its nature, parallel or concurrent programming is not always easy to implement. However, there are things we can do to make things a lot easier. Personally, I prefer to use channels to communicate between threads. In my opinion, this leads to good code hygiene and a clearer code base in the long run. Channels are also fairly easy to implement, and I think they're a lot easier to use than mutexes and locking. So in this tutorial I have 4 examples, each increasing in complexity. Some of these examples are straight from the Rust documentation. The first example is simple. 3 threads are spawned and a handle is returned from the thread spawn function. This handle is used with the join function below, whose task is to wait for the 3 threads to be executed. Once this has been accomplished, the for loop is run. In this example, there is no communication between threads. This is a bare bones thread example. The second example uses channels to communicate between threads. Also notice the move keyword in the closure in the spawn command. The Rust documentation reminds us that this keyword is used before the parameter list of the closure to force the closure to take ownership of the values it uses in the environment. Translated, that means you can move data from one thread to another. Notice the emphasis on the word move, which also implies a change of ownership. It may happen that you will need to copy using the clone keyword certain elements of data for them to be used in another thread. When you run the channel function, a tuple is returned, which can be used to send and receive data. So in this case, the TX channel is used to send the value. After this thread has been run, the RX channel receives the information sent on the channel. One thing that is reassuring in practice is that channels are robust, and it is rare that something is sent on one channel and not received on the other. In other words, you can have confidence when using channels. The third example is nearly identical to the second, except that it uses a for loop and has a delay of 1 second in sending. The fourth example is probably the most useful from a learning standpoint. What is of special note is the clone of the channel, which has been placed in the tx2 looping function variable. What this function does is form a worker thread, which can be run permanently if you wish in the background. Then a receiving reader thread is also spawned. What this function does is form a worker thread that can be run permanently in the background if you wish. Then a receiving reader thread is also spawned, which can also be run permanently in the background. In this case, the receive command is used in the loop, but you could also use a try receive command, and this would create a non-blocking thread or non-blocking read. In that situation, you would be advised to use some form of sleeping function so that CPU cycles are not unnecessarily used. Also note the finish code constant that sends a message from the sending loop to the read loop to exit. So in effect, there's an interact between the read function and the looping function, and this is all connected by these 2 functions. I've used this technique with great effect in trading software that I wrote. Once again, in practice, I found threads and channels to be very reliable in Rust and easy to debug, provided that you have good code hygiene. I hope that you found this tutorial helpful. Thank you for listening and watching.